Today we shall round up the topic waves, after which exercises will follow. This will be like revision questions to help you see if actually you understood the topic. Our lesson today shall be on graphs. In maths, you've seen graphs. You've seen graphs in even the previous classes, from 1, from 2. You can even name many types of graphs. You have distance time graphs, velocity time graphs, and all the rest. All those are examples of graphs. Now, assuming you understood the different definitions of the key terms used in waves, in this lesson, we shall see how to apply those definitions in solving graphical problems. All the definitions given are very important because you will need to apply each definition under graphs in order to look for what you've been asked to look for. Graphs generally are used to display informations, but our graphs in this lesson will be used to display informations about waves. And we shall use two types of graphs. These are the two types of graphs that are always used to display informations about waves, which are the displacement time graphs and the displacement distance graphs. Taking the displacement time graph, when you hear displacement time graph, what comes to your mind? How does the graph look like? On which of the axes is the displacement and on which of the axes is the time? That is, where do you plot the displacement of the wave and where do you plot the time taken by the wave? All these are taken into consideration. Now, a displacement time graph is a graph of displacement against time. That is, you plot the displacements on the vertical axis and the time taken on the horizontal axis. And this displacement time graph gives information about the period of a wave, the frequency of a wave, the amplitude of a wave, and the speed of a wave, as can be seen on the figure below. Now remember, the amplitude, the speed, the period, the frequency of a wave can be gotten from a displacement time graph, provided you know their different definitions. So it will be important for you to understand the different definitions before looking at problems under graphs. Without the definition, you will get lost. Now, taking a look at the displacement time graph in front of you, you have the displacement on the vertical axis and you have the time on the horizontal axis. Displacement in centimeters, which can also be in meters, and time in seconds. The wave starts from the initial position, that is 0. If you take a displacement distance graph, the two are different. Displacement time graph is a graph of displacement against time. Displacement distance graph is a graph of displacement against distance. Some of you might get confused, saying displacement and distance are the same thing. No. Displacement, remember, is a vector quantity, while distance is a scalar quantity. So the two are different. So on this graph, the displacement is on the vertical axis, while the distance is on the horizontal axis. This graph generally gives information about the amplitude of a wave and the wavelength, as can be seen in the figure below. The figure has the displacement placed on the vertical axis and the distance on the horizontal axis, with the initial position of the wave being 0. And the wave travels towards x. Remember, this is just an example of a transverse wave, the traveling of a transverse wave. Take a look at this example. Look at the graph given to you. What type of graph is it? It can be clearly seen that it's a displacement time graph. Mind you, the displacement is in meters and the time is in seconds. Now, the displacement is from 0 to 3, while the time is from 0 to 8. What actually do you get from this graph? What information can you get from this graph? If I were to ask you what is the amplitude of the wave, what would you say? Or what is the wavelength of the wave? Or give the period of the wave. Give the frequency of the wave. All these informations can be gotten from this graph, provided you remember the definitions of amplitude, frequency, period, and wavelength. You can see that the maximum displacement of the wave from 0 is 3. The wave does not go higher than 3. It doesn't go above 3. So 3 is the maximum displacement of the wave from its initial position, 0, which gives the amplitude of the wave to be 3. If I ask you to give the wavelength, you remember the definition of a wavelength. Give the period, you remember the definition of a period. Frequency, you remember the definition of the frequency. So the period would be 4. And why is it 4? Because it took 4 seconds to make one complete oscillation. From 0 to 4 is one complete oscillation. That is a complete wave. And so it took 4 seconds to make that one wave. And since frequency is the inverse of period, we can easily get our frequency to be 1 over period, which is equal to 1 over 4, giving us 0.25 Hertz. Take the next example, example 3. Look at the graph given. What type of graph is it? It is a displacement distance graph, because the vertical axis shows the displacement in meters, while the horizontal axis shows the distance in meters. information can you get from this graph? The maximum displacement being 2 from 0. You can actually get the amplitude, which is the maximum displacement from 0, and it gives 2. And the wavelength is 4. Why is it 4? From 0 to 1 to 3 to 5. Before 5, we already have one complete wave. And so the point that marks one complete wave is at the point 4 meters. Remember, it is calibrated in a difference of 2 meters. From 0 to 1, 1 to 3, 3 to 5 to 7 to 9. So a complete wave is made at the point 4. So the wavelength of our wave is 4 meters, meaning from 0 to 4 gives us a complete wave. Now let's take the next example. From the graph below, calculate the period, the frequency, the amplitude, and the speed at point B. I believe from the previous examples, you can actually give the amplitude from this graph. You can give the period, you can give the frequency. What would the period be? Remember, period, the time taken to make one complete oscillation, the time taken to make one complete wave. So at what point does the wave make one complete oscillation? At what point on the time axis does the wave make one complete oscillation? You can see that it's at the point 2, meaning at the point 2 seconds. So the period of this wave will be 2 seconds. Not forgetting the fact that frequency is the inverse of period, which gives frequency equals 1 over t. We have our frequency to be 1 over 2, which gives 0.5 seconds. What will you say the amplitude is? What is the maximum displacement of this wave from 0? It can be clearly seen from the graph to be 6, which gives the amplitude of the wave to be 6. Now, the last question is, calculate the speed of the wave at point B. Now, you have to be technical in answering this question. The speed of the wave at point B. Now, at point B, what is the displacement of the wave? What you do is you extrapolate from point B right up to the displacement axis. That gives 6. You also extrapolate from point B downwards to the time axis, which gives 2.5. Now, from the two equations of speed, which is F times lambda or X over T, which of the equations can you use to calculate the speed at point B? You cannot use the equation F lambda equal to V because you don't have the wavelength. So you're left with just one equation to use, which is V equals x over t, x being the displacement, t being the time. And from the graph, we saw that the displacement was 6 meters. The maximum displacement from 0 was 6 meters. And the time at that point B was 2.5 seconds, giving us the velocity, that is speed, to be 6 over 2.5, which boils down to 2.4 meters per second. With the given solved examples, I believe it will be very easy to calculate the exercises, to answer the questions under the exercises given.